Hello everyone. Today I'll start the continuity. In this chapter, our main motivation or main goal is uh, what is continuity of function and how to find continuity in mathematical way, and that's all in this chapter. Okay. First, try to understand what is the continuity. Okay. So continuity, actually we have a function. Then we have to check the function is continuous or not at a point or at a interval. Okay, so whenever a function have something break, like assume this is my function, this is continuous because this function from here, if I take from here to here, the function have no break, that means function is continuous. If there exists any break here, so I can say that at this point the function has discontinuity. Clear? So first, I'm writing the definition, proper mathematical definition of continuity. Continuity of a function, continuity of a function. A function, I am writing mathematical definition only. Same thing. A function f of x is said to be continuous. Is said to be continuous at, at an interior point. Interior point means, I will tell you, interior point, uh, its domain if limit extending to a, f of x is equal to f of a. This is our main condition. Okay, so this definition says that a function f of x is said to be continuous at an interior point in its domain, if limit extending to a, f of x equal to f of a. What is the meaning of that? The mathematical way I can define, you know the left hand limit of right hand limit of a point. Left hand limit is equal to right hand limit of that point where x equal to a, we are checking at x equal to a point now, is equal to f of a. This is the condition of continuity at the point x equal to a, mathematical condition. Okay, so now I told you that now continuity, assume the function is continuity at the end point of the interval. Continuity, I think definition is clear. Continuity at the end point, at the end point, of interval. What is the meaning of that? Assume the function is defined from like closed interval a b to r. Assume, okay, we have to check the function is continuous or not. So interior point means all point which is belonging to ab. That means interior point, if I draw like that, assume this is my function and this is my a and b interval. Assume, okay, all point in between ab, not av, in between ab is called the interior point. Clear? In this interval, clear? So now if we want to check the continuity of the end point of the interval, I told you for the interior point you have to check this condition. But in the case of endpoint, I told you continuity at the end point of it. That means A point and B point. How to check? Just find the right hand limit for the case of x equal to A. If this is equal to f of A, then you can say that the function is continuous at A point. Okay, no need to check the left hand limit of A. Same way for the case of B, just tell me your by your concept or your intelligence, you can say that you have to check only left hand limit at x equal to b. If this is equal to f of a, then you can say that the function is continuous at the point of b. Clear? So I think this concept is clear. Now when you can say that the function is discontinuous, continuity I think clear. in the interior point and in the end point. Clear? So discontinuity. Whenever a function is not continuous at some point, this is called discontinuity. Clear? So function is not continuous, that means the function is discontinuous. So discontinuity type is so many types. I can say that. 1 minute, let me think. What is the continuity condition? Was continuity? You have to imply left hand limit equal to right hand limit equal to f of a. Okay, this is my continuity condition. That means if one of them, means one of condition is not satisfied, then you can say that the function is discontinuous at that point. Okay, either the possibilities case, how many possibilities I can get? Either LHL both are exits but not equal to with RHL. Clear? This is first condition. Second condition may be LHL equal to RHL, but this is not equal to f of a. Clear? Also maybe there is another possibilities which is LHL and RHL both are does not exist. Okay, does not exist, you can say. So this type of possibilities can be happen. Clear? So that time you can say that the function is discontinuous. Clear? So this type, whatever I told you, this type have some name. The name is first one, if both limit, if first conditions I told you here, first left hand limit and right hand limit both are exits, okay, but not equal. I'm writing here both exit, both are exits but not equal, not equal. This is that case now. That time this is called the first kind discontinuity. I'm writing here first kind discontinuity. Clear? And sorry, second point it says that left hand limit and right hand limit both are equal. That means both are finite number equal, but not equal to f of a. This is called, this case is called removable discontinuity. Sorry, removable discontinuity. Why removable discontinuity? That means in this way they are defining that if I changes the value of f of a, that means assume left hand limit and equal to 2 and right hand limit also equal to 2, but a functional value, corresponding functional value is 3. So this is the discontinuity because this is not equal to 2, but I can redefine now. If I redefine, that means f of a equal to, if I define 2, then function is continuous. So that's why the name of this type of discontinuity is called removable. That means you can remove and redefine it. Okay, and case of the third case, one of the right hand limit or left hand limit does not exist. This is called the second kind discontinuity. Clear? Second kind, okay, discontinuity. Second kind discontinuity. I think clear. So three types of discontinuity. Okay. Now some useful result on continuity. Continuity discontinuity. I think clear. Now some useful result. First one says that if f and g both are continuous at a, first, if f and g two function continuous at x equal to a, this point, then I'm writing f plus g, that means sum of two function is also continuous. Clear? Second function f minus g continuous. Third, f of g also continuous at x equal to a, all are same. Fourth one, f by g continuous also, x equal to a point, but here additional condition was g of a not equal to sorry, not g, g of a not equal to 0, otherwise this become 1 by 0 for. Okay, clear? So this is the f and g continuous function, like algebraic operation. Okay, assume f is continuous. Second case, f is continuous, f is continuous, one minute, at x equal to a, and g is continuous, g of x, whatever, g is continuous at f of a. Okay, try to understand. If is continuous at x equal to a, g of x is continuous at f of a, then you can say that g of, means this is composition, this function is continuous at x equal to a. Second property. Third one, if f is continuous at x equal to, if f is continuous at x equal to a, and g of x is discontinuous, okay, then f into g, or f into g, here this is not composition, f into g may or may not be continuous, may or may not continuous. Clear? All polynomial function is continuous, all polynomial trigonometric function and inverse trigonometric function, inverse trigonometric function and logarithmic function, log function, and what is called that of like exponential function, sorry, exponential function, exponential functions are all are called continuous function. Clear? Some problem based on it. First, first one, first problem, f of x equal to e to the power box x plus x minus 1 divided by box x plus x not equal to 0, 1, x equal to 0. Then check the option. First one, uh, this is right hand limit at x tending to 0 is equal to minus 1. Second option, left hand limit, same, x tending to 0, f of x is equal to 1 by e minus 1. Third, it is continuous, this function continuous. And fourth option, this is discontinuous, continuous at x equal to 0 and discontinuous at x equal to 0. I have to check. So I told you the condition that whenever you are trying to find the continuity and discontinuity, you have to find the at first left hand limit, right hand limit, then that should be equal to f of a. Okay, first the left hand limit, how to, I, you know now how to find the left hand limit of that function, corresponding function at x equal to 0. So I am writing directly limit h tending to 0 negative, and in place of x you have to write 0 minus h. Clear? So e to the power box of 0 minus h, yes or no, in the limit chapter I already covered that. Okay, so that's why I am writing directly. So 1 minute, plus 0 minus h minus 1 divided by box 0, 0 minus h plus 0 minus h. Okay, so tell me one thing, what is the box function 0 minus h value? That give you minus 1, obviously, because h is small positive number. So minus of small positive number which is less than 1, that means equal to minus 1. Clear? So also I told you the in limit chapter, So h tending to 0 negative, this become minus 1 e to the power minus 1 plus, oh sorry, minus h minus 1 by minus 1 minus h. Okay, now this become, look here, if I put h equal to 0 here, then what will happen? This become e to the power minus 1 by minus 1. That means 1 minus e inverse. Okay, this is the left hand limit, but left hand limit told that 1 by e minus 1. Okay, 1 minus 1 by e, 1 minus 1 by e, but this is not exactly true maybe. Okay, because of we got 1 minus 1 by e, but given that 1 by e minus 1. Okay, this is wrong. Okay, now let's right hand limit, find right hand limit. Limit h tending to 0 positive, you have to replace 0 plus a is here, plus 0 plus h minus 1 divided by 0 plus h. Now tell me one thing, what is the value of box 0 plus h? So box 0 plus h will give you 0 value because of h is something positive number. So it to the give you 0. E to the power 0 means 0 plus h minus 1 divided by h. Sorry. This give you the 0 ray. 0 plus h. This is h. So if I put 0 value, then that becomes 0 by 0 form. Okay. So limit h tending to 0 plus 0 by 0 form means you have to apply L'Hospital rule. So e to the power h derivative, e to the power h 1 derivative 0 by 1, that means 1. Clear? So but given that maybe minus 1. Yes, minus 1. So RHL RHL not equal to LHL. This is obviously discontinuity. Okay, so now tell me one thing, what kind of discontinuity is this? Look here, this is both are finite but not equal. That means it may be first kind. Let's check once. I also forgot. LHL and nautical both exist. Nautical first kind. First kind. Okay, so this is first kind of discontinuity. Now second question. The function is f of x equal to x sine 1 by x, where x not equal to 0. Okay, then so that the function is continuous, the function is continuous at x equal to 0. So what is the value of the function? You have to find the value of the function. Find the value of the function. Okay, given that, try to understand. Oh, okay, options are 0, b minus 1, c 1, and d indeterminate. Okay, so the given function is this one, x sine 1 by x, so that the function is continuous at x equal to 0. Okay, so find the value of the function. Okay, so I have to first find left hand limit. Limit h tending to 0 negative, that means in place of x you have to write 0 minus h sine 1 by 1 minus h. This is correct. Okay, now limit h tending to 0 negative minus h sine, this is 0 sine minus 1 by h. Okay, minus minus would be cutted. Next step, 0 h sine 1 by h. Okay, whenever this is going to 0, okay, try to understand, h tending to 0 and sine 1 by h, this is, you can say that the finite quantity. Okay, so okay, I want to say something. Just tell me, what about limit x tending to 0 sine 1 by x? This is the oscillatory, you can say that oscillatory limit, because why? This sine 1 by x, when x tending to 0, the graph should be, this is 0, Okay, the graph should be sin x rapidly here and there, but in between 1 to -1 always. Okay, that means they give you finite quantity but not a fixed quantity. They are oscillating between 1 and -1. That's why this is become like, you can say that this is not a finite number. But whenever I am multiplying with h, that means multiplying with 0, so this becomes 0 into a finite quantity. Yes, this is not exactly have limit but have some finite quantity now. So this is finite quantity, you can say that finite quantity. Okay, so that's why 0 into something finite quantity, what value? This give you 0 now always. Okay, clear? I think clear. So right hand limit same way, limit h tending to 0 positive, and limit 0 plus h sine 1 by 0 plus h. Clear? So same way this is also give you 0. Clear? So right hand limit and left hand limit is equal to 0, and also given the given the means the questions in questions, they tell to means and that, so the function is continuous at x equal to 0. The function is continuous at x equal to 0, it is given. Clear? So I can say that the since RHL and this is equal to LHL, right hand limit and left hand limit are equal, this is also equal to f of a value now, a what? 0. So f of 0, since all are equal to 0, then you can say that the corresponding functional value, the question is asking for find the value of that function corresponding, so the functional value should be equal to 0. So correct option is a. Okay, now third question, given function f of x equal to x plus 1 whole to the power 2 minus 1 by mod x plus 1 by x, x not equal to 0, and 0 when x equal to 0. Okay, so you have to check the continuity. Option are discontinuity at only one point, second option, discontinuity exactly two point, discontinuity uh, at 2 points, third option, continuous everywhere, continuous, and third option, none of the above. Clear? So I have to check the continuity. Okay, look here in this question, the point, that means function changes its value at x equal to 0. That means either the function give you the discontinuity at x equal to 0, man, that means I want to say that the function can give you only discontinuity point is x equal to 0 only. Otherwise the function x to the power something, whatever the function is given, that function is continuous everywhere na. So where means whenever you look that the function is changes its sign, or sorry, not sign, the function it changes its value at some point, then you can verify that that point the function is continuous or discontinuity. Okay, so here only means we can observe that x equal to 0 point the function changes its value. So let's check the continuity at x equal to 0 point. First, right hand limit at x equal to 0, limit h tending to 0 positive, f of x 0 positive means not exactly 0, so in place of 0 plus h plus 1 whole to the power 2 minus 1 by modulus of 0 plus h plus 1 by 0 plus h. Am I right? This is correct. So from here, limit h tending to 0, h plus 1 whole to the power 2 minus 1 by modulus of h, this always give you h 1 by also h. Look here, then h tending to 0, h tending to 0, h plus 1, 2 minus this become 2 by h, 2 by h. Clear? So look here, if I put h equal to 0 here, okay, So uh, 1 minute, limit h tending to 0, let's break down also, square minus this is minus now, so h plus 1 whole to the power 2 by h. Yes, I can write obviously 3. Okay, so look here, this is become 1 because if you put age equal to 0 here, this become 1. But look here, for this case, this become 1 to the power infinity for yes or no. So if whenever I have, I told you x tending to infinity or x tending to 0, as in 1 plus x to the power 1 by x, this give you e value. So apply that only. So above value give you 1 and the below value is this part. This part I have dotted, this part give you, okay, I'm writing, don't worry. Limit h tending to 0, h plus 1, 1 by h whole square. Yes, 1, this is 1 by h. So this is 1, 1 to the power infinity form. The value is e, so 1 by e square. Clear? So this is the right hand limit. Okay, now find left hand limit. Same way, I have to change only 0 minus h. Let me check. Limit h tending to 0 minus 0 minus h plus 1 whole to the power 2 minus 1 by mod of minus h plus 1 by minus h. Clear? So this is equal to limit h tending to 0 negative, and this become 1 minus h whole to the power 2 minus, look here, this should be cutted. Yes, so this becomes 0. That means if I put that value 1 whole square, this become 1. That means right hand limit and left hand limit are not equal, because this is 1 by e square, this is 1. So right hand limit not equal to left hand limit. So the function is discontinuous only at a point, that means x equal to 0 point. This option is correct option. Question